Hello everyone, welcome to this video. In this video we are going to see the solution to initial value problem. So let's discuss with the example that we were continuing in our previous video. We need to calculate or find the solution f of the differential equation dy upon dx is equal to 2x such that whenever we have the value of x is equal to 1, we get the value of f as equal to 4, correct? So we see that here y is equal to x square plus c is the solution to this differential equation. You can check this by verifying it as this satisfies this differential equation. How you can calculate the first derivative dy upon dx here by differentiating it with respect to x, so that you will get 2x, which is the same as your differential equation, correct? So here c is the arbitrary constant, and this is a one parameter family of solutions. Why? Because you have only one parameter involved here. With different values of c you get different solutions. However, we are required for that particular solution where when we have the value of x as equal to 1, the value of y should be equal to 4. So that means our solution should pass through this point 1, 4, correct? So let's calculate the value of c. That's very easy. We can substitute the value of x is equal to 1 and y is equal to 4 here, so that our c come out to be equal to 3. Hence you obtain the value of c as 3. Hence this become y is equal to x square plus 3 becomes the solution of the differential equation, which passes through the initial point 1, 4, correct? Okay, moving forward on to another problem. I have selected this problem because here you'll see in a moment. The problem is we are given a second order differential equation which is d2y by dx2 plus y is equal to 0. So you see this involves a second order derivative here. So here two initial conditions are given to us. One is given for y, that means it says that whenever the value of x is equal to 1, the value of y is equal to 3. And the second initial condition says that whenever the value of x is equal to 1, the value of the derivative, first derivative, is given to be minus 4, right? So these two conditions are given to us. So this is again an initial value problem because we are given the same point here. The point is x is equal to 1, and for this we are given different values of y and its derivatives, correct? So I am saying for this particular kind of differential equation, why two initial conditions are required? Why not 1 or why not 3? Or do we have any specific criteria so as to how many initial conditions do we have? Yes, there's a specific criteria. The criteria says that if you have a second order differential equation, you will have two initial conditions or two boundary conditions. If you have the nth order differential equation where the nth derivative is involved, then you would have n initial conditions, or you would have n boundary conditions as n when required. That means if your differential equation is initial value problem, then you would have n initial conditions, and if it is boundary value condition, then you would have some domain here which would have n such boundaries, correct? We'll be discussing about boundary values and boundary conditions in the upcoming videos. So here, why two initial conditions are required? Because when you are going to solve this kind of differential equation, in its solution you would have the solution in terms of x. So you would have some function of x here plus some constant ax something plus, right, b. So you would have two constants here, a and b. So in order to get the values of these two constants, two conditions are required, right? So we'll make use of these two initial conditions to determine these two arbitrary constants, which you can substitute in the solution and get back the solution. Moving forward to our third problem, we have to solve this initial value problem where it is given that dy upon dx is equal to minus x upon y, and the initial condition is given to be y of 3 is equal to 4. So this is a differential equation whose solution is nothing but one parameter family of solutions, which is this x square plus y square is equal to c square. So it is basically what? The family of circles, right, having different radius, and all of them are centered at the point 0. So you would have it like this, right? All of them, they are circles actually. Okay, so with the different radius you have different values of you get different circles. So but we are to find that particular circle which satisfies this initial condition, right, which satisfies through this point. So that means whenever your x is equal to 3, the value of y should be equal to 4. So we are required that particular circle which passes through this point 3, 4. So what we'll do, we'll substitute the values of x and y into the solution and obtain the value of c from here. We get the value of c square as 25. We can substitute back into our solution. So our solution becomes x square plus y square is equal to 25. Now what would be the value of y? You see, we have two branches of solution here. One is the positive branch, which is plus square root 25 minus x square, and another is the negative branch, which is minus square root 25 minus x square. Now which one to choose, or can we choose both the solutions? The answer is no, you cannot choose both the solutions. Why? Because you see, for the initial condition x is equal to 3, we have y is equal to 4, because this is the condition that is given to us. For this, only this positive condition is being satisfied, this condition is not satisfying, hence we take only the positive path here, hence it's become the solution to our initial value problem. So I hope with this video, following various examples, you are clear with the basic idea of solving initial value problem. We will be talking in more detail about how to calculate the solutions to different various differential equations once we are done with the basics. In the next video, we'll be discussing about the boundary value problem. So well, that is it for this video. Thank you for watching.